close your eyes and imagine. Since the dawn of humanity, a companion has always been there. Silent, patient, and full of mystery. A celestial body that has shaped our history, culture, and life on this planet. We call it the moon. The moon is more than a simple light in the night sky. It's the pulse of the tides, the keeper of time, a beacon for explorers, and an endless source of inspiration for art and poetry. But behind its familiar beauty lies a dramatic story. A story that begins with a cosmic catastrophe, a catastrophic collision, and humanity's relentless journey of discovery. We see it every night, but do we truly understand it? How did a celestial body like the moon come into existence? Why does it always show us the same face, like a silent promise? And what secrets remain buried beneath its desolate surface? Today, we'll embark on an adventure through space and time. We'll explore the moon's origin, delve into ancient myths and beliefs, and witness humanity's greatest achievements in reaching for the nearest star. This isn't just a story about a celestial object. It's a story about us, our curiosity, our courage, and our unwavering desire to reach for the stars. Hello, welcome to Astronomical Library. To understand the moon, we must travel back in time. Back to the violent and chaotic early solar system, approximately 4.5 billion years ago. Back then, our Earth wasn't a peaceful blue planet, but a fiery sphere of molten rock, constantly bombarded by countless asteroids. Yet, the biggest and most dramatic event was still to come. A cosmic disaster that would reshape Earth's destiny and create the moon. According to the most widely accepted scientific theory, the giant impact hypothesis. A Mars-sized protoplanet, which scientists named Theia, was on an unavoidable collision course with the early Earth. This wasn't a gentle nudge. This was a high-speed collision, a catastrophe powerful enough to forever change both worlds. In that fateful moment, they struck Earth at an oblique angle, a glancing blow that saved our planet from complete destruction. The immense energy of the impact vaporized most of Theia and a significant portion of Earth's outer crust. All of the molten material, vaporized rock, and massive debris were launched into space, forming a massive, fiery ring around Earth. For thousands of years that followed, gravity did its slow, inevitable work. The debris in the ring began to collide, clump together, and accumulate. They gradually built upon one another, forming a new celestial body. This object grew larger and larger, pulling in more material from the ring until it coalesced into the moon we know today. The scientific evidence supporting this hypothesis is compelling. When Apollo astronauts brought back lunar rock samples, scientists analyzed them and found that the oxygen isotope composition in lunar rocks is nearly identical to that of Earth's rocks. This suggests they share a common origin. Similarly, the moon's small iron core is explained by this model, as most of Theia and Earth's iron cores merged deep within our planet after the impact. The giant impact hypothesis not only explains the moon's birth, but also why Earth has an unusual axial tilt compared to other planets. The collision tilted the Earth, creating our seasons, and also explains why the moon always shows us the same face. While science paints a picture of the moon's formation from a cosmic collision, ancient cultures across the world had their own colorful and mysterious explanations. To them, the moon was not just a physical celestial body, but a deity, a symbol, or an explanation for their very existence. These stories are not scientific truths, but they are truths of belief, culture, and imagination. In Christianity, the Bible describes the creation of the moon as part of a divine plan. According to the book of Genesis, on the fourth day, God said, "Let there be lights in the dome of the sky to separate the day from the night, and let them be for signs, and for seasons, and for days, and years. And let them be lights in the dome of the sky to give light upon the earth." The moon was created alongside the sun and stars, not from a chaotic impact, but from a divine intention with the clear purpose of serving life on earth. Similarly, in Islam, the moon is mentioned in the Quran as a sign of Allah's power. The Quran states that Allah made the sun a shining lamp and the moon a light. This distinction between the sun as a primary source of light and the moon as a reflective light is not only scientifically accurate, but also carries a deep symbolic meaning. The crescent moon is not just a marker for the start of a new month in the Islamic calendar. It is also a symbol of hope and spiritual guidance. In ancient mythologies, the moon was often personified as a deity. In Greek mythology, the goddess Artemis was the goddess of the moon and the hunt, representing wild beauty and independence. In Roman mythology, the moon goddess was Diana. The stories of these goddesses are often linked to the protection of nature, fertility, and guardianship. Eastern cultures also have their own stories. In Hinduism, the moon god is Chandra, a revered deity who rides a chariot pulled by 10 white horses. Myths about Chandra often revolve around adventure, love, and challenges. The Chandra myths not only explain the moon's existence, but also connect it to moral and philosophical tales. Another familiar narrative is the legend of the Jade Rabbit, found in Chinese, Japanese, and Korean folklore, and the similar story of True Cui in Vietnam. These legends provide an explanation for the dark markings we see on the moon's surface. In the Asian legends, the rabbit is a selfless being who sacrifices itself, and as a reward, is taken to the moon to pound the elixir of life. In the Vietnamese story, a man named Cui holds on to a magical banyan tree that flies him to the moon. These legends, though different, all share a common thread: humanity's desire to fill the mysterious void of the cosmos with stories of our own, making the moon more relatable and human. Thus, from a religious and mythological perspective, the moon was not born from a violent collision, but from a grand design or a deeply human story. These tales have shaped our festivals, rituals, and even our history, demonstrating that the moon is significant to us, not just for its physical properties, but for what it represents. For millennia, the moon was a distant dream, a silent invitation from the heavens. We looked up at it, drew it, and wrote about it, but it remained another world. That all changed in the mid-20th century, when a dramatic race began, not on Earth, but in space. This race was a fierce competition between two global superpowers, the United States and the Soviet Union. The goal was not just to prove technological superiority, but to conquer the moon. It began with the launch of Sputnik, the first crewed flights, and then, the unforgettable moment in history, the Apollo program. The Apollo 11 mission, a triumph against all odds. The Apollo program was one of the greatest human achievements ever. Hundreds of thousands of people worked tirelessly to turn a dream into reality. The culmination of this effort was Apollo 11, a mission that pushed the boundaries of human knowledge and endurance. The crew of this historic flight consisted of 3 legendary astronauts: Commander Neil Armstrong, Lunar Module Pilot Buzz Aldrin, and Command Module Pilot Michael Collins. The mission began with the thunderous launch of the massive Saturn V rocket, a 111-meter-tall behemoth that carried the hopes of a nation into orbit. The journey to the moon took 3 days, a tense period where the crew had to perform critical maneuvers, including separating the command module and docking with the lunar lander. The most critical and dangerous part of the mission was the lunar landing itself. As the Eagle lander descended toward the Sea of Tranquility, a series of computer alarms blared, threatening to abort the mission. With fuel running dangerously low, Armstrong took manual control and skillfully navigated the lander away from a boulder-strewn crater, eventually finding a clear spot. He famously radioed back to Mission Control: "Houston, Tranquility Base here. The Eagle has landed." It was a triumph of human skill and quick thinking against immense pressure. Armstrong's first steps were a quiet, surreal moment. He described the surface as a fine, powdery sand, and famously noted the magnificent desolation of the lunar landscape. Aldrin, who followed him, described the view of Earth as a brilliant jewel in the blackness. The 2 astronauts spent just over 2 hours on the surface, collecting 21.5 kilograms of lunar samples, taking photographs, and planting the American flag. They also left a plaque that read, "Here men from the planet Earth first set foot upon the moon." July 1969 AD. We came in peace for all mankind. Their mission was fraught with tension and peril. The ascent from the moon's surface was nearly aborted, after a crucial circuit breaker switch, which was needed to fire the ascent engine, broke. Buzz Aldrin, in a stroke of genius, used a pen to push the switch, saving their lives and ensuring their return. Their journey back to Earth was a long, anxious wait, and upon splashdown in the Pacific Ocean, They were immediately quarantined to prevent any potential lunar pathogens from spreading, a fear that highlighted the deep uncertainty of this historic voyage. The Artemis Program, the new age of lunar exploration. Today, humanity is returning to the moon with a new purpose. The Artemis Program isn't just a brief visit. It's a blueprint for building a lasting human presence. Its core purpose is to establish a sustainable base on the lunar South Pole, where water ice has been discovered. This water is a game changer, as it can be converted into drinking water, breathable air, and rocket fuel. This resource will be the key to making a self-sufficient lunar colony a reality. The preparations for Artemis are extensive, involving the development of the powerful Space Launch System, SLS rocket, and the Orion spacecraft. The program also includes an international effort to build the Lunar Gateway, a small space station orbiting the moon that will serve as a staging point for missions to the lunar surface. Astronauts will live and work on the Gateway before making their final descent to the moon. Over the next 50 years, the ambition of the Artemis program is to build a self-sufficient lunar colony. This colony would act as a vital scientific outpost, a mining operation for precious resources like helium-3, and, most importantly, a launch pad for future missions to Mars and beyond. The moon will no longer be an endpoint, but a stepping stone, a permanent part of humanity's expansion into the cosmos. The Artemis missions are planned to be more frequent and longer lasting than the Apollo missions. Future astronauts will not only collect samples, but also conduct long-term research on lunar geology, astrophysics, and the effects of low gravity on the human body. The ultimate vision is a future where the moon serves as an economic hub, a refueling station for interplanetary travel, and a symbol of humanity's permanent presence in space. The journey to conquer the moon is a story of more than just technology. It's a story of bravery, perseverance, and the relentless human desire to understand our place in the universe. I will make detailed videos about the two Apollo 11 programs and the Artemis program in the next videos. Please subscribe to the channel to watch the earliest and most complete information about these two programs. Beyond its scarred and ancient surface, the moon is a world of unique physical properties that set it apart from other celestial bodies. For a long time, we saw it as a static, dead rock, but modern science reveals a more complex picture. The asymmetrical world, the near and far side. One of the most profound mysteries of the moon is the dramatic difference between its two hemispheres. The side we always see, the near side, is dominated by vast, dark plains called Maria, Latin for seas. These are massive, smooth basins formed by ancient volcanic eruptions that filled immense impact craters. The near side's crust is also significantly thinner, allowing magma from the interior to flow more easily to the surface. In stark contrast, the far side, which was completely unknown to humanity until the Soviet Luna 3 probe in 1959, is rugged and heavily cratered, with very few Maria. Its crust is much thicker, preventing the large-scale volcanic activity that smoothed out the near side. This asymmetry is a puzzle that scientists are still working to solve. The prevailing theory suggests that the gravitational pull of the early Earth may have influenced the distribution of heat and magma on the moon's near side, leading to its thinner crust and more volcanic activity. The lunar surface, a timeline of cosmic violence. The moon's surface is a pristine record of the solar system's violent history, without a thick atmosphere to cause erosion or active plate tectonics to recycle its surface. Every crater, every scar tells a story. Craters. The moon is pockmarked with billions of craters, from tiny pockmarks to enormous basins, hundreds of kilometers wide. They were formed by impacts from asteroids and comets over billions of years. The age of a lunar surface can be estimated by the density of its craters. Older surfaces have more craters. For example, the ancient lunar highlands are much more heavily cratered than the younger Maria. Regolith. The entire surface is covered in a layer of fine powdery dust and broken rock, called regolith. This regolith is the result of countless meteorite impacts breaking down the lunar rock. It has a unique, abrasive quality that proved challenging for Apollo astronauts, damaging their spacesuits and equipment. The lunar interior, a slowly dying heart. Our understanding of the moon's interior comes from seismic data from the Apollo missions. These instruments recorded thousands of moonquakes, which are much weaker than earthquakes, and are primarily caused by tidal forces from Earth's gravity. The seismic waves from these tremors revealed a layered structure. Crust, the outer layer, with its varying thickness, is a cold, solid shell. Mantle, beneath the crust, is a thick, mostly solid mantle. Core at the center is a small, partially molten core of iron and possibly sulfur. However, this core is not large or active enough to generate a significant magnetic field like Earth's. This inactive interior is the primary reason the Moon is a geologically dead world. It lacks the internal heat to drive volcanoes or tectonic activity, which explains why its surface remains a time capsule of the ancient past. Tidal locking, the eternal dance. Perhaps the Moon's most famous characteristic is its tidal locking, the reason we only ever see one side of it. Over billions of years, the gravitational pull between the Earth and Moon slowed the Moon's rotation until its rotational period perfectly matched its orbital period. It's a gravitational dance that has left the far side of the Moon, forever hidden from our view on Earth. This perpetual dance is a testament to the immense power of gravity and the delicate balance of celestial mechanics. The Moon is far more than a beautiful object in the night sky. It is a gravitational partner whose presence has shaped our planet in fundamental ways. Its influence is both subtle and dramatic, affecting everything from our oceans to the very stability of our planet. The rhythmic dance of tides and tidal locking. The most visible effect of the Moon's gravity is its control over the tides. The mechanism behind this is a fascinating interplay of gravitational force and inertia. The Moon's gravity pulls on everything on Earth, but its effect is most noticeable on the liquid oceans. This pull creates a bulge in the ocean on the side of Earth, facing the Moon. However, there is also a second bulge on the opposite side of the planet. This bulge is created by centrifugal force, or inertia. As the Earth and Moon orbit a common center of mass, the ocean on the side furthest from the Moon is thrown outward, away from the Moon's pull, creating a second high tide bulge. Tidal cycle. As Earth rotates, any given point on its surface passes through these two bulges in approximately 24 hours and 50 minutes. This is why we experience 2 high tides and 2 low tides each day. The 50-minute difference is because the Moon is also orbiting Earth, so it moves a little bit each day. Spring and neap tides. The tides are also affected by the Sun's gravity. When the Sun, Moon, and Earth are aligned during a new moon and a full moon, their gravitational pulls combine, creating extra high tides and extra low tides. These are called spring tides. When the Sun and Moon are at a 90-degree angle relative to Earth during the first and third quarter moons, their pulls partially cancel each other out, resulting in weaker tides. These are known as neap tides. Impact of tides on Earth, humans, and wildlife. The tides are more than just a daily inconvenience for beachgoers. They are a fundamental force that has shaped life on Earth for billions of years. Impact on the planet. The constant friction of the tides on the ocean floor and coastlines has a profound effect on Earth's rotation. This friction acts as a cosmic brake, slowly slowing down our planet's spin. This is why our days are gradually getting longer. Simultaneously, this energy transfer causes the Moon to move farther away from Earth at a rate of about 3.8 centimeters per year. This tidal braking has also influenced the Moon's rotation, leading to a phenomenon known as tidal locking. Over billions of years, the Earth's gravity slowed the Moon's spin until its rotational period matched its orbital period, leaving one side of the Moon permanently facing us. Impact on ecosystems. Tides are the lifeblood of coastal ecosystems. The constant ebb and flow creates intertidal zones, unique habitats that support a vast array of plant and animal life. Organisms in these zones, such as barnacles, mussels, and crabs, have evolved to survive in a harsh environment that is alternately exposed to air and submerged in water. Tides also help to circulate nutrients and oxygen, sustaining estuaries and mangrove forests, which are critical nurseries for countless marine species. Impact on human civilization. For millennia, human societies have used the tides to their advantage. Coastal communities have relied on tidal cycles for fishing and navigation. Tidal charts were essential for sailors to know when to enter or leave ports. In the modern era, tides are being harnessed as a source of renewable energy through tidal power plants. which use the kinetic energy of the moving water to generate electricity. The silent guardian, stabilizing Earth's tilt. Beyond tides, the moon plays a role of cosmic proportions. It acts as a stabilizer for Earth's axial tilt. Earth is tilted at an angle of approximately 23.5 degrees, which is what gives us our seasons. Without the moon's immense gravitational influence, the Earth's axial tilt would wobble erratically, swinging from 0 degrees to as much as 85 degrees over millions of years. This wild fluctuation would cause catastrophic changes in our climate. Imagine a world where the equator could become ice-covered, and the poles could become temperate within a matter of thousands of years. Such a chaotic climate would have made the long-term evolution of complex life, including humanity, incredibly difficult, if not impossible. The moon is, in effect, the silent guardian of our planet's climate, providing the stability necessary for life to thrive. However, the friction created by the tides slows down Earth's rotation, making our days slightly longer over billions of years. In return, the moon is slowly moving away from Earth. Through a process called tidal acceleration, the moon is gaining energy from Earth's rotation, causing its orbit to expand. The moon's slow departure, an inevitable future. The moon is currently moving away from Earth at a rate of about 3.8 centimeters per year, roughly the same speed your fingernails grow. This is not a cause FDIA concern, but it does raise fascinating questions about the distant future. The hypothesis of a distant moon. In billions of years, the moon will be so far away that its gravitational pull will be significantly weaker. The tides will be minimal, and Earth's rotation will slow to the point where a day might last for weeks. This change would lead to extreme climate shifts and fundamentally alter our planet's weather patterns. Hypothesis of collision, a different kind of catastrophe. While the moon is currently moving away, some theoretical scenarios suggest a different fate. In the very distant future, as our sun becomes a red giant and expands, it could disrupt the gravitational balance of the solar system. The moon's orbit could be destabilized, potentially leading to a catastrophic collision with Earth. However, this is an extremely low probability event, and it is merely a theoretical possibility in a time so far in the future that humanity as we know it would likely no longer exist. Ultimately, the moon is the most influential neighbor Earth has. Its gravitational presence has slowed our rotation, stabilized our climate, and shaped the very rhythm of our planet. Its story is inextricably linked to our own, from the first life that formed in the tidal pools it created to the human pioneers who first set foot on its surface. So, the moon is not just a silent observer in our night sky. It's a key player in our cosmic story of a violent birth, a patient guardian, and a future full of possibilities. From its creation in a cataclysmic impact to its role in stabilizing our climate and shaping our tides, the moon's influence is profound and undeniable. As we look up at the moon, we're not just seeing a rock in space. We're seeing a testament to our own journey of exploration and discovery. The Apollo missions were just the beginning, and the Artemis program promises to take us back to the moon and beyond. The next chapter is being written now, and you are a part of it. If you enjoyed this deep dive into the history, science, and future of the moon, please give this video a like and share it with others who are fascinated by the cosmos. Don't forget to subscribe to the Astronomical library and hit the bell icon, so you don't miss our next adventure into the universe. Thank you for watching, and keep looking up.